Room library is now officially available for a Kotlin multi-platform targeting Android and iOS, which is why I have prepared one simple project to help you learn how to set up and implement the local database for these two platforms. This application will have three screens. Home, where we are displaying all books, and we have an option to sort those same books by their favorite property. The details screen will display all book information. We will have an option to update some of the data, mark that book as a favorite, but also remove that book from the database as well. Finally, the Manage screen will be used to insert or update the book information that we pass to it. So bottom line, all CRUD operations are covered in this video. Without further ado, let's get started. We're gonna build this app from scratch. As you can see, I have already generated an empty Compose multi-platform project targeting iOS and Android. It's really easy. Just go to the KMP wizard website, select your target platform, check the option to share the UI and click download button. Pretty straightforward. Next, we need to add all dependencies that we're gonna use for this project. Since this should be a rather simple project, I'm gonna open up the version catalog file and specify the following. Compose navigation library that will help us to implement the navigation in our application. The next one is a landscapist, which is an image loading library that contains multiple artifacts for a coil, glide, and a fresco. In this case, we're gonna use coil 3, which is available in a Kotlin multi-platform. The next one is a coin dependency injection library, and here we have a few artifacts. The first one, we're gonna need to pass a context object in our Android target. Then we have the artifact for the core functionality, compose, as well as a view model. And finally, there is a room, which is a local database library available for a Kotlin multi-platform. We have three artifacts: a runtime, compiler, and SQLite bundled, which is a database engine. After those dependencies, don't forget to add the room and the KSP plugins as well. And that's everything we are gonna need. We can now go back to the Compose app Gradle build file and add all those dependencies in the common main source set. Except for the coin Android artifact, which should be placed inside the Android main source set. I will show you later why we need that. Anyhow, don't forget to specify those two plugins in the project level and the module level Gradle build files. And you may have already noticed that we are missing one dependency, which is a room compiler. That's because compiler needs to be specified inside a dependencies block at the end of this file. So here in this block, we need to add this artifact for all the targets that we are targeting with this project. In this case, that's Android and iOS for various architectures as well as the iOS simulator. Besides that, there is only one more thing that we need to add in this Gradle build file, and that is the location of the database schema. So the schema directory function specifies a directory where a room library should output the database schema during the build process. And these files contains the schema of the room database, which can be helpful for migration purposes and debugging. Okay, so the next step, we need to define our database table along with all fields that we're gonna have. So create a new data class and annotate it with the entity annotation. That's how we're gonna tell the room library that this will represent our database table. So the first field is the ID, and it will represent a primary key in this table. Next, we have the image that should be used to save an image URL of the book cover, because we shouldn't store the whole image objects inside the database. Next, we have the title of the book, the summary, the category. We have a list of multiple different tags. We have is a favorite boolean value to indicate whether a user has marked this book as a favorite or not. And finally, we have the author of this book as well. So after we have defined this entity or the database table, now we need to declare a DAO or a data access object. So DAO is used to abstract and manage interactions with the database. It provides methods to perform CRUD operations in the database. And we're going to define all possible functions and operations that we're going to need for our project. So, first, we need a function to insert a book object in the database. This function needs to be annotated with the insert annotation that will indicate to the room library that we are actually inserting an object. The second function will be used to update an existing book object. So don't forget to specify this update annotation and pass a book parameter to indicate which object we are actually updating. I will also paste here a couple of more functions where I have defined custom SQL queries by myself. So we have a function to get a book from the database by passing a book ID. This function should be used from the details screen to fill in the data from a selected book. We also have a similar function with a different return type, which is Kotlin Flow. The reason why we need Kotlin Flow here is because I'm going to observe in real time whether this isFavorite property has been changed. And you will see about that. Also, when using a flow as a return type, you don't need to specify a suspend keyword, otherwise you should always include it. Next, we have a function to read all books from the database, as well as another one to read all books where we're gonna sort them by isFavorite field. After that, we have a function to set or update this isFavorite field of the book, and the last one to delete the book from the database by specifying a book ID. Perfect. So now we have defined our DAO, and the next thing we need to define a database class itself. Create a new abstract class that implements a room database class. Within this class, we need to declare an abstract function that returns the same DAO that we have already defined. So this class should be annotated with a database annotation, where we need to specify and pass all entities or tables that we have defined. In this case, that's only one. Below that, there is the database version. So this is also a place to increment the database version when implementing database migrations. And when doing migrations, you should also make sure that you have this export schema property equal to true. Now, one thing which is different in a Kotlin multi-platform is that you need to annotate your database with a constructed by annotation. And this annotation is used to define how a class, particularly the room database class, should be constructed on different platforms. It will help us to ensure that platform-specific implementations are correctly applied. Now, we don't need to specify the actual declarations of this constructor, which is why we just need to create an expect declaration for this constructor that needs to implement a room database constructor itself. Inside, let's override the initialize function and specify our database as a return type. So, even though this is actually an expect declaration, we don't need to define actual declarations on our own, because a room compiler will do that for us instead. So just be sure to add this suppress annotation to avoid compile time warnings. Great. And the last thing, we also need to define our own custom type converter. Because in our database table, if you recall, we have one property or a field that has a type of a list. And the room library by default doesn't know how to save or read that value or that type, which is why we need to define our own custom type converter. So just create a simple class with two functions, annotate them with the corresponding annotations. Inside the first function, we need to make sure to specify how to save that value in the database, and in the second function, how to read that same value from our database. Perfect. Now that we have defined most of the skeleton of our database, we need to provide a database builder for each target platform. So the database builder is important in order to successfully construct our room database later. First, let's handle the Android part. So inside the Android main source set, I'm gonna create a directory with a new Kotlin file. Within that Kotlin file, I'm gonna add a simple function with a context as a parameter. Because in Android, we do need the context object to provide the database builder. So here we are using a getDatabase path function, which provides the full file path of the database file. This path is typically within the internal storage area dedicated to the app's database on Android device. This ensures that the database is stored in the appropriate location. After that, we are calling a database builder, passing the Android context as well as the absolute path of the database file. Great. Now goes the iOS part. So inside the iOS main source set, I'm gonna create a folder with the same Kotlin file that we have created in the Android main source set. That way, it will be better to maintain our project structure and we can easily locate that same logic in both targets. For the iOS part, we don't need the context object. Instead, to get the document directory of the database that we're gonna create, we need the help of a NS file manager. So we are using the NS file manager to get the URL of the documents directory in the user domain, which is a standard directory for storing a user-generated data. If this function is successful, then we are returning the file path of this directory as a string. And finally, we can pass that document directory along with a database name to a room database builder. Perfect. So after we have described how to provide a database builder for each target, we need to inject that same type with the help of a coin library. So create the new directory with the file coin module. I'm gonna create here an expect declaration for the coin module that we're gonna declare separately on each target platform. This target module will be used to provide an instance of the room database builder for each target separately. Next, feel free to generate the actual declarations for Android and iOS, so that we can provide that instance as well. On Android part, we can call single function to provide the singleton for this type, and just call that function that we have created previously. Of course, on Android we also need the context object. And for now, just pass here a get function, which is going to tell the coin library to search this context object in its module, because now I'm going to show you how to provide that context as well. So let's go back for a moment to our coin module Kotlin file and create a function that will be used to initialize coin library on each platform. Here I will add an optional coin application scope parameter that will be used on an Android platform to provide the context. Then we are invoking that config parameter if it's not null and passing the target module as well. Afterwards, let's create an application class inside our Android main source set, then override the onCreate function, call the initializeCoin function, and for the config parameter, we want to provide a context object to coin. This Android context function is a part of the coin library, only available in the coin application scope. And that's the main reason why we have implemented that dependency for the Android coin artifact. So it will help us to provide that same context object to our Android database builder. Also, don't forget to add this application class to the Android manifest file so that we can tie this class to our application lifecycle. Now, for the iOS target module, we can simply call that function without passing any extra parameters. And also, don't forget to call initializeCoin function to initialize it when the iOS application is launched. Great! So that's how we have injected a room database builder for each target platform. So now that we have a room database builder, we can finally provide the instance of our actual room database. So in the common main source set, I will create the new Kotlin file with a function to get the database. So this function will accept a room database builder as a parameter, and it will return the instance of our database class. Then, in the coin module file of our common main source set, create the new variable called shared module. So here we want to describe how to inject that database class as well. Just call that getDatabase function and pass get as a parameter, which will tell coin library to search for that room database builder that we have already injected in the target module. So with this, we have provided an instance of our database, which means we can use all our database operations from our application. So we have completed the part of this tutorial where we have handled the room database for both Android and iOS. Now we're gonna focus on adding the navigation in this application, create and implement a few screens, and add the logic to interact with the database. At the time of recording this video, a type-safe navigation is not available for a KMP yet, which means that we still need to define our destinations by using the hard-coded route values. But nevertheless, we're gonna have 3 screens right here. Home, that will display all books from the database. Then we have the details screen that will be used to load all the information from the selected book, which is why this destination needs to take an integer ID as a parameter, so that we can know which book from the database to show in the details screen. Finally, the Manage screen will have also this same parameter of an integer type, this time with a default value with a -1. So when we pass a -1 to this screen, it will indicate that we want to create the new book. And if we pass the value greater than that, it means that we want to load any information from a selected book, so that we can update and modify some of its data, of course. We can now proceed and create the navigation graph. So this function will be called from the app Kotlin file to pass the nav controller. Plus, the start destination will be the home screen. We can also define 3 composables for each screen that we're gonna have. And for now, just leave them empty. Home screen should be the first on our to-do list. So I'm not gonna spend too much time building the UI itself and showing you how to use the basic Jetpack Compose components, because I already assume that you are familiar with that part, because you're obviously watching this video. I will quickly create 2 common UI components. The first one will be a loading view that should display a circular loading indicator to represent when the data is being loaded. The second UI component will be called the error view. So this one will be used to place a text on the center of the screen and display an optional error message. If this parameter is not specified, a default text will be empty. Perfect. So after those 2 UI components, I will create one useful wrapper class called requestState. I have been using this wrapper class in most of my personal project, and it works really good. So this one will be used to wrap our data and indicate whether the data is loading, it's ready to be displayed, or even if we encounter an error. We have a couple of functions also to check the state of this data, as well as extract the data and the error message from this wrapper. Below all of that functions, I have added one more composable function, which will immediately animate the transition between multiple states of this wrapper class. Finally, let's create the home screen Kotlin file inside the presentation directory. So after that, the home screen composable. So this composable should take 2 parameters. The first one on book select, which takes an integer value which represents an ID of the selected book. This lambda should navigate the user to the details screen, where we should take that ID and fetch the book with that same ID. The second parameter is on create click, which should be triggered after we click the floating action button. So this action will trigger the navigation to the manage screen, to which we are passing -1. And we are passing the -1 because in that screen we are expecting to create the new book when we pass that negative value. And you will see about that. Anyhow, inside this composable I will add the scaffold with a top app bar. Within the top app bar, specify some kind of a title. We can add the floating action button as well, and trigger one of those two lambdas from the parameters of this screen. Alright, so I will add here also a sorting icon inside the top app bar that we're going to use to sort the books based on their isFavorite value. The on-click lambda of this icon button will be handled a little bit later. Great. Now it's time to create the view model for this screen. This will be our first view model. So within this view model, we're gonna inject the book database class that we have already described in the coin module. Before we continue furthermore with this same view model, let's open up the coin module for a moment, and within the shared module, I'm going to inject that home view model with a database instance. Here you can see that I'm using a new syntax which makes our code look more cleaner, because we don't have to pass that get function explicitly. Coin compiler is smart enough to figure that out on its own. Alright, so now we can go back to our view model, and on top of this class I will create one stateflow variable that will be used to indicate whether the user has toggled an option to sort books by the favorite property. This will be important because whenever we initialize the view model, we want to make sure to trigger an appropriate DAO function based on this value. If this value is true, we want to call read all books sort by favorite, or otherwise just read all books. Here we are also collecting the flow based on this boolean value of our stateflow parent. So far so good. I will add here two more variables to hold the list of books that we're gonna read from the database. This variable will be updated within those two collection blocks above. Finally, let's add the function to toggle this isFavorite stateflow variable that we're gonna trigger from the UI. Awesome. Now go back to the home screen and use coin view model function from the coin library to directly inject this view model inside the composable function. Below that, just observe those two variables that we have declared inside the view model. Within the scaffold component, I will use that display result utility function from the request state, and based on its state, we want to display a proper composable function. A loading view when the data is being loaded, and an optional error view if something bad happens. Finally, a lazy column if we successfully fetch the data. Also, if that data is empty, we can display an empty message on the screen by calling the empty view with no parameters. Awesome. There is just one more UI component that we need to create in order to display each book in this lazy column. So be sure to create a book view composable. This composable will take two parameters. A book object that we can use to extract that data and fill out those components, along with the onClick lambda. Here we are using the coil3 library to load an image from an image URL. Then we have a one star icon that should be visible only if this isFavorite property of the book is equal to true. This star icon is used to indicate our favorite books. And on the right side of this row, we are displaying a title and a summary of the book, where we are of course limiting the number of lines because there is a limited space in the lazy column. Okay, now let's go back to the home screen and place this component within the lazy column to display that for each book object in our database. Finally, we do need to trigger that logic for the sort icon to sort those books by the isFavorite property. I will quickly add here the coroutine scope along with the lazy list state, because when we sort this list, we also want to animate the scrolling on top of this list as well, because of a pleasant user experience, of course. With all of this, we have completed our home screen. And we can freely launch the application on Android emulator and quickly check out and see how this UI actually looks. After you launch this application, you should be able to see an empty message on the center of the screen, because we still haven't added any book in our database. And that's the part for the Manage screen. The next screen that we're gonna build is called Manage screen. So here we will have multiple text fields where we can enter the information about the book that we are trying to create. But also, the screen will be used when we want to update an existing book. That's why this screen accepts an argument of an integer type. So if that integer value is -1, it means that we are trying to create the new book. Otherwise, we will load an existing book information and fill in our fields with that data. The first thing before we continue, let's define an integer value as an argument for this screen. An integer argument cannot be null, which is why a default value should be set to -1. Then, in this composable, we also want to extract that ID that we receive and pass it down to the screen composable. Now, we need to create the new screen. So, add the new package and the Kotlin file to host this composable. I'm gonna add here two parameters, the ID argument and on a back-click lambda that should trigger the logic to navigate back to the home screen. Within this composable, I'm gonna add the scaffold component, then the top app bar with the title that will be calculated dynamically, based on the ID value. So if we pass a -1 as an ID, the title should say create, otherwise update. I will add here also a back arrow as the navigation icon and a trigger data lambda from the parameters of this function. After that, we need one more icon button that should be dynamically calculated as well. So if we are passing a -1 as an ID, we want to insert the book in the database. Otherwise, we want to trigger an update operation instead. The logic will be added a little bit later. So before we add all those text fields inside this screen, let's create the view model. As with the previous one, we're gonna inject here the database, but also a save state handle object. Because that object is automatically provided by the view model when we initialize it in the scope of a composable function that accepts an argument. We're gonna use that save state handle object to fetch the ID argument and retrieve it in the view model. Next, let's create here a couple of mutable state properties to hold the text for each text field from the UI. Since I have already mentioned that for this demo tutorial I will use an image URL for this book cover, just create a constant with some default book cover image URL. Then, when we initialize the view model, we want to check if that ID is not -1, and in that case we want to update those text field properties right away to reflect the data from a selected book. Below this init block, we just want to create two functions to insert and update the book data. Each one of those two functions will take two parameters, onSuccess and onError. Before we trigger any database operation, we also want to validate those fields. Now, this is just a basic validation, but in a real-world scenario, you might want to add a little bit more than that. Anyhow, if everything goes right, insert the book in the database and trigger onSuccess lambda. Otherwise, trigger the onError. The similar logic should be added for the update book function. Only in this case, for the isFavorite property, we are passing the value which is already saved in the book. The logic for updating this property will be implemented later in the details screen. Great. Now, before we initialize this view model, don't forget to inject it in the shared coin module like we did before. Great. So, now in the Manage screen composable, let's initialize that view model and observe all these properties that we have defined. They will be passed to each corresponding text field down below that we define in the scaffold. And after we define all those text fields, we can add the logic in that icon button to trigger either insert or update operation, based on the ID value that we receive. So with this, we have completed this screen and we can launch the application to try and insert one book in the database. As you can see, a start destination is home. So press the floating action button to navigate to this manage screen. When navigating here, we are passing a -1, which is a default value that indicates that we're gonna trigger the insert operation when we click the button. Feel free to fill in some information about the book in those text fields. And I'm even gonna paste here the custom image URL as well. And then just click this add button on the top right corner. When this button is triggered, we are calling the insert function, and if everything goes right, we are navigating back to the home screen, where that new book will appear. Perfect. And the last screen that we're gonna be implementing will serve the purpose to display those book information in a more formatted way than we have it in the manage screen. So whenever a user selects one of the books from the home screen, we're gonna launch the details screen. Like the previous screen, this one will also have an integer argument which we need to declare in the navigation graph. Here, a default value will be 0 instead of the -1, because we are sure that the only positive values will be included, since the first ID number in the database will be 0. Within this composable, create the variable that will hold that argument that we receive. After that, create the new package along with the file in which we're going to be hosting this new screen. We need only two parameters, a lambda to navigate back to the home screen and the lambda to navigate to the manage screen if we decide to modify some of the information from this book. Pretty simple. Now, within this composable screen, let's add a scaffold along with the top A bar. The navigation icon should be used to send the user back to the home screen. In the action parameter of this top A bar, I will declare 3 icons. So the first one should be used to navigate to a manage screen to edit the book information. The second one will be used to mark the selected book as the favorite or to remove the favorite mark from an already marked book. The third one should be used to delete this selected book from the database. Great. So next we need to implement the view model for this screen. As before, we want to inject the database as well as the save state handle to fetch that ID argument. We want to fetch that selected book ID value. And also create 2 mutable properties. For the book, with an initial value of null, but also is a favorite property so that we can change the alpha state of the star icon to fully visible or less visible based on its value. You'll see about that. Anyhow, whenever we initialize this view model, we want to get that ID argument and fetch the book from the database. In the flow collection block, we are also gonna update those 2 variables on the top. Below this initial block, we're gonna add 2 more functions. The one that will be used to toggle this is favorite property of the selected book, and the other one to actually delete this book from the database. Awesome. So before we initialize this view model, don't forget to inject it into the shared module, and afterwards we can call the view model and observe those 2 properties. The isFavorite boolean value should be used to mark that star icon as a fully visible or a less visible based on its state. When we click this button, we also want to trigger that logic to update this field of the book. On the other hand, when we click that delete icon, we want to delete the book from the database and navigate back. Lastly, inside the scaffold, I will add a couple of UI elements to properly display those book information on the screen. As you can see, we are using the coil3 image component to load an image, then a couple of text elements and the chip components for those tags fields in our book. A simple UI, right? Now, we are ready to launch this application once again and confirm that everything works as expected. First, we're gonna select that book that we have previously created and see how this detailed screen looks like. We can mark this book as our favorite by toggling this star icon on the top. If we go back now, we should be able to see that yellow star icon on top of our image. For the demonstration purpose, I will create one more book just to see and test the logic for sorting these books based on their isFavorite field. And as you can see, everything works as expected. When this star icon is toggled, those books with is favorite property equal to true will be placed on the top of the list. Perfect. Now let's again select one of those two books, click the edit icon on the top, then modify some of its information in this manage screen, and we should be able to see those new changes right away. Lastly, we can also try removing one of those two books from our database, so just select the book and click the delete icon on the top. Voila, everything works perfect. And that's it. So that's how you can create a simple book library application in a Kotlin multi-platform targeting both Android and iOS. I have showcased how to successfully set up this room library in the multi-platform environment. Plus, this project is available as a repository on my GitHub profile, so feel free to check it out in more details. Don't forget to leave a like as well as a comment below this video if you wish to support my work so that I can keep providing high quality content. Thank you for watching.